It's a beautiful sight, but it's also a little deceptive. Because while those stars seem close enough to touch, the reality is mind-bendingly different. Let's talk about our closest stellar neighbor, a small, dim star called Proxima Centauri. After our own sun, it's the next star over. Sounds simple, right? Well, next door, in cosmic terms, is 4.24 light-years away. That means if you could travel at the speed of light, the fastest anything. Now, what if we try to go there with our current technology? Let's take our fastest rockers. If we launched one today, pointed straight at Proxima Centauri, it would take around 75,000 years to arrive. That's longer than all of recorded human history, too. But here's why that journey is so tempting. Orbiting Proxima Centauri is a planet called Proxima-b. And what makes this planet so special is that it sits right inside the habitable zone of its star. That's the sweet spot where temperatures are just right for liquid water to exist on the surface. And as far as we know, where there's water, there's a chance for life. So, we have a potentially habitable Earth-like world right on our cosmic doorstep, sheer. The ultimate question is, can we ever actually get there? Launched way back in 1977. It's been traveling for over 4 decades, and it's now in interstellar space. But if Voyager 1 had been aimed at Proxima Centauri, it would still need about 70,000 more years to complete the journey. The core problem, as you might have guessed, is speed. We just can't go fast enough. The heavier the rocket, the more thrust you need just to get it moving. And needing more thrust means you need more fuel. It's a vicious cycle, called the tyranny of the rocket equation, and it's the biggest roadblock to interstellar travel. To reach Proxima Centauri in a more reasonable time frame. Say 100 years, our spacecraft would need to travel at about 4% the speed of light. Our fastest probes today barely reach 0.06%. The gap is enormous. So, the real question isn't just can we go, but how do we ever go faster? This is where the brilliant minds of scientists and engineers come in, exploring ideas that sound like they're straight out of science fiction. One promising technology is the ion engine, instead of a massive, explosive launch. Ion engines use electricity to accelerate charged particles, creating a very gentle but continuous thrust. They accelerate incredibly slowly, but over months and years in the friction-free vacuum of space. They can reach speeds far greater than any chemical rocket. Then there's nuclear propulsion. This concept involves using the immense energy released from nuclear reactions to power a spacecraft. It too provide far more power than chemical rockets, but it also comes with immense risks. The idea of launching a nuclear reactor into space is, understandably, a major safety concern. But perhaps the most futuristic idea being seriously considered is the light sail. Imagine a massive, ultra-thin, reflective sail attached to a tiny spacecraft. Back on Earth, a powerful array of lasers would be aimed at this sail. A project called Breakthrough Starshot aims to do just this. By hitting it with a powerful laser beam, they hope to accelerate it to 20% the speed of light. But even if we solve the speed problem, new dangers emerge. O2, at 20% the speed of light, even a tiny speck of interstellar dust becomes a catastrophic threat. The impact would be like a bomb going off, potentially vaporizing the probe instantly. And space isn't empty. It's filled with radiation, micro-meteoroids, and extreme cold that can fry electronics and destroy systems in a heartbeat. And then there's the communication delay. Light takes 4.24 years to travel from Proxima Centauri to Earth. That means any message, any picture, or any data sent back from the probe would take over 4 years to reach us. And if we needed to send a command back, say, to correct its course or investigate something interesting, that command would take another 4 years to arrive. There, the challenges are almost unimaginable. They would face bone density loss and muscle atrophy from living in zero gravity. They would be exposed to cosmic radiation, increasing their risk of cancer. And the psychological toll of complete isolation. Generations might be born, live their entire lives, and pass away inside that ship without ever setting foot on a planet. So maybe, in the beginning, humans don't go. Maybe our machines go for us. We could build highly advanced AI probes, designed to travel for thousands of years. They wouldn't need food, sleep, or companionship. They wouldn't feel loneliness or despair. They could patiently make the long journey, carrying the legacy of our curiosity with them. And then there are the truly theoretical ideas, like antimatter reactors or even warp drives. Most of these ideas are still just dreams. They exist on whiteboards, in complex equations, and in the imaginations of visionaries. It will represent so much more than just a picture of a distant planet. It will be the ultimate proof that humanity was never meant to stay home. We were built to explore, to push our limits, and to reach for the stars. Thanks for watching. If you're fascinated by space and our place in the universe, be sure to subscribe for more journeys into the unknown